supposed to be very interactive. So I'm from Kenya. I'm so sorry. You've seen the energy I'm coming on the stage, right? Yeah, so we're going to talk to each other. This is not a talk where I'm the one speaking, dishing out knowledge. I'm sure we have people in this room. I listened to the keynote, man. I listened to the keynote. Who was here for the keynote? Who was here for the keynote? I'm challenged.
Hello?
Huh? So I listened to the keynote because nothing short of amazing. I also promised to deliver in my talk. But now the thing is, the Wi-Fi is kind of throwing us out, but I'm still trying to have my handle demo on stage for all of you.
Okay,
so it's, what's the time?
Yeah, he's already there. Let me tell you.
12:30? 35. So I have 30 minutes to stage. And I would like to take 30 minutes to go through what I have today. So for my standing, I am Brayan Kai Mwanyumba. As I say, you can call me Kai, you can call me Brayan, you can call me Mwanyumba. I'm okay with all of them. I am a GitHub campus expert. How many know GitHub campus? You only know about GDEs, you only know about Google Developer Experts, right? We will also have GitHub Campus Experts. This is a program for student community leaders across the world to build and lead communities in their cities, in their universities. So we had applications open up last month, and the applications are closed, and these processes have been sent back. I was lucky enough to be part of those who are reviewing applications that have been sent to this cohort. I have to say that we really need more of campus experts in the sub-Saharan Africa region. In Kenya, we only have one female campus expert, which is not okay. So let's catch up after the session, talk about the application process, and how we can apply next year in February when the application is open. I'm also a Google Developer Student Club lead at my university back in Kenya, at Kabarak University. I also co-organize the biggest hackathon in Rift Valley region. Brings together all the universities in the Rift Valley region. It's called Luna Hacks. We organize it together with other amazing individuals. Then give them a shout out. Phyllis, Atieno, Clifford, Dohuma, all of them. We bring it to life together with them. I volunteer at Open Source Community Africa, Nairobi. I'm lucky to have my lead brother, Diana, shouting at the back. I'm also passionate about, I'm an advocate for diversity, equity, and inclusion, and I decided to channel my technical writing skill to that cause. So I write articles for She Code Africa, Nairobi, technical articles to help young women and girls build a career in tech and thrive in the tech ecosystem. And I also recently started writing articles for Pycon Uganda. I also skate and swim. I come from the coastal region of Kenya, so we have ways to do. My work here is not to make it hard for you, it's to make it so easy for you that you want to do it once I'm off the stage. So, when you are kids, and you of course, you don't understand what your mom says, right? So when you're told, don't touch that pan, it's hot, you don't get it. But once how does your mom communicate with you that actually that thing is hot, and you should not touch it? She lets you go, right? She lets you touch it first. And after that action is now when you know, okay, so this is something that is hot and I shouldn't be touching it next time, right? You can't understand, but he used some action to make you understand, right? So, when you say, hey Google, when you say hello Bixby, or when you say hi Alexa, how do they understand human language and yet they are computers, yet they are machines? See, we know that machines understand zeros and ones, right? That is very basic. They understand mathematics. Zeros and ones. So how do they convert your hello Bixby, hello Alexa, or hi Google to something that they can now actually respond to you? That is now what I'm going to talk about. What? Embeddings. Now you understand the topic. What I'm going to talk about, right? I feel like you have mics all over. Because my joke is, I need to hear people. Maybe someone can help me pass the mics to few people who are willing to chat with me as I talk. Okay, sure. So someone can help me do that. So we have chatbots that are revolutionizing systems all over the world. Chatbots that are helping customer services and all that. Who has interacted with the chatbot? Who has interacted with the chat? You have never interacted with the chatbot before. No one, right? So chatbots are not part of our life. They are helping interpret human language in a way that they can understand and provide seamless customer service to everyone. If you go to Safe, I'm sure Safe Border has a chatbot, right? Jumia has a chatbot. Everyone has a chatbot. And we also have, so all that, from chatbots to beating benchmark scores. So we have AI answering systems that are beating benchmark human scores made by humans. So how are they able to do all that? To understand human language to an extent that they can write an essay that actually beats what you can write as a human being, right? So all this is happening because of what we call natural language processing, and specifically today I'm talking about one aspect of it. So, but how do algorithms and machine learning models understand human-created data? So how do they get to a point where you write, for example, yesterday you are trying to download that Safe Border app, so you are not able to go around quickly. So when I type on the chat, okay, I'm so and so, how is it able to interpret it and now give you feedback on something about the same? So when you talk about machine learning is mathematics. Me not talking about math here will be doing a very bad thing, because ML is mathematics, right? For those who did outreach internships about building models, without having a fundamental understanding of how the math behind it. Yes, the math is done by programs that you write, but you need to understand what happens behind the scene in the mathematics. So it does all that because you have the concept of vectors in mathematics. We all did vectors, right? I did it when I was in I don't know, in Kenya it's a different education system, right? We don't do the same as here, but I did it in my high school level. So I'm sure most of us understand the concept of vectors, right? Or even if you don't understand, like, I've heard of this before. Where did I hear this thing called vectors, right? So, but no, it's not something big that will push you away from what I'm covering. But what exactly are vectors, and how does it all boil down to what embeddings, what I'm going to talk about today? So in a snapshot, this is what happens. This is what you're seeing on your screen. So they take the text data, they tokenize it. So when I say tokenizing, it's just that I'm taking hi Alexa and breaking it down to hi and Alexa. You know, I'm now having it in words, in bits. So I'm like tokenizing it. And then after that, we know that machine learning is all about data, and if you get data, you have to process text data. We remove numeric and punctuation. Because if I add a comma, is that really important to what I'm communicating? It's important to us human beings, but for machines, it's not really. For us, we have to understand like intonation and all that, but for machines, it's not like that important. So we remove numeric punctuation, removing stop word, stemming and dematization. We'll get into what is stemming and dematization. Then we have feature engineering, where we now get the features, we have what becomes or bank of words, the TF-IDF, what embeddings, and after what embeddings now, we now build and train that model and evaluate that model. So, this is a where we interact, right? So how many of you have laptops here in this room that they can follow along? Even if you don't have a laptop, you can follow along with your phone. Scan that code. You can follow along, even with your phone. Just scan that code and we do this together with all of you. I'm not sure if you can now switch to the demo part. Will you go to get it? The demo. So, yeah, but the good thing is, after the demo, then I'll come to all that. But I want to go through the demo with all of you. Are you able to see the demo on your phone? Oh, if you could see the QR code, maybe you can bring up. Okay, sure. So what I can do is, we are all on GitHub, right? Okay, if you're not on GitHub, also okay, but you can just go and search. Follow, yeah, you can just screenshot the slide that has the QR code, so that they can scan and we go together. Oh, so yeah, no, the one that's the one above. Yeah, that one. So then it's like show it. So what I'm going to show you today is I don't want this concept to be so hard for you to follow along. I understand probably most of us are just getting into the field of machine learning, right? But we also have experts here in machine learning, and you will also help me along as I keep, so keep scanning the code as I try and explain this concept. So I will first, we know machine learning is about data. You can't have machine learning if you have data, right? We first have to have the data to build our model. So we will first come from that concept of data. Now I will take you slowly by slowly from the concept of data, walk with you through to how you clean your data, slowly, how now the concept of mathematics comes in, and now how you build your model after the word embeddings process. Because you see, for you to build your model, you have to have passed the word embeddings process, right? Yeah, so all of us are good to go. I know the Wi-Fi can be challenging, even for me here. Hey, but we shall survive, right? We shall manage. It's totally okay because it's many of us and we have to share it all together. It's called brothers and sisters, right? So it's very good we are sharing it, but it also has some disadvantages. So if you can use your own MTN data bundle, it will be totally fine. So you can switch to the demo side. So since now maybe I'm not able to control it with this, I'm control it with this one. No, so I'm tempted to either go down or up. Sure. So this is what I've explained. I've explained. So you can go read this on your own in your own time. But this is just even after I'm done with my job, be able to get my story and understand everything. So we have chatbots all over the internet that are revolutionizing systems, and doing amazing things. So we can just go to text cleaning. What you can do is you can follow that. Okay, sure. So the first thing you're going to do is you're going to start by getting a text data, right? So we are first going to get text data, and from that text data, we are going to take it bit by bit, clean that data step by step, and see how easy these things are, right? It's okay. Since they have it in their phones, you can just read this way. So now you can scroll down. Go down again. Up to text, you can start text cleaning at the bottom. Okay, text cleaning. Nice. So now we want to start with how we can clean our data. Like you have to, when you respond to that chatbot on the website, or when you respond to that email, and it automatically gives you response. How does it do it? Right? You want to know how does it happen behind the scenes. So the first thing, this is a Python concept. So we have a Python interpreter we need to first import, which is called the URL request. We now use that to download the text. For us now, I'm giving you like a simulation of the step, a demonstration. So we'll download the text from that book, and now from there, so that is the code that you just use import, and all that, import, and then you download the text from that book, and then we now decode the text with a list of compression. So you can see, you can just go down. Okay. So just scroll down again. But you can follow along from your phones, right? If you can follow along from your phone, and I can also follow along from my laptop, we should not depend on that, right? Okay. Okay, sure. So the first thing is, if you are not close to someone who has a laptop, you can try and also view it from your end, because it happens during presentations. But I want to respect your time, as actually we have another session coming in. I wouldn't want to take much of your time, but I still really want to go through this, because this is actually not the peak of the session. So now, once we, it can, amazing. Modern solutions for modern problems. So I can control it from here. So, okay, so we go here. So now we decode the text. So by decoding the text, you see now when someone writes, they have full stops, commas, spaces, and all that. But I want to just have it as a simple text where I don't have to like do anything. I don't want the commas and all that. So I don't want the spaces. This is a paragraph and all that. So I do that. And then after that, I print out that text. So this is the text that I've printed, which is poor level of blah 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 blah. So that is the text that you're having. So you can now imagine this is the text that you're sending in on that chatbot, right? This is the text that you're now sending in on that chatbot. And after that, now we tokenize. And I'm saying, so this Moby Dick is now completely captured in text, so that is the book you are reading. And next, we need to tokenize. And when I say tokenize, we're just breaking the document into words. So we see that we have poor level of the sub appears who have gone through the norm. So now we want to have poor, therefore instead of breaking it into words. So we use these big terms in machine learning, but it's a very simple thing. Tokenizing is just breaking it into words. Yeah. So let's continue. So we can easily do the tokenization process by we can easily do the tokenization process by just splitting. You see this part, I just say token is equal to text.split. So in just a single line of code in just that keyword, I'm able to split that in this part. I'm able to split that into the text into different words. And then the split function splits the text in on white space. So white space is any space that you have in the text. So you are able to split it and now have it as 13, wheelbarrow, chapter, and everything. But now, this is the thing. Will these numbers help us in anything? Yes, they can help us in maybe saying that, hey, I ordered my self order at 1404, right? But it can also be an hindrance in us building the national language processing application we want to build. And also you can see that you have some that are capital letters, all of them, some are with capital letters, some are small letters, and also some have like full stop inside them and commas inside them. Now what we want to do is we want to only remove alphabets and remove all the numbers from the text. So let's now remove all the alphabets and the numbers. You can follow along from the phone. If you can follow along from either your phone or laptop, it's totally okay. So So often we want to ignore capitalization of words. So we lowercase all the words. So we first, but to lowercase just take text.lower. Your token is equals to text.lower and you are able to lowercase all your words. And after that, we remove punctuation. So, okay, so let me go. Yeah. So we only alphabetic if I want to have only alphabet, but also I have removed all the commas, the full stops, and now I have everything as an alphabet, and everything is one letter. So you see, like this text is now a little bit cleaner, right? And you can use it in other. Now after we've done that, and you see the code is really easy to follow along. Token is equal to token 1 for 1 token. If the one is alpha, right now. So if the one is alpha, just filters out all numeric characters. So all the numeric characters that are removed from that are remaining only the letters. So let's keep going. Yeah. But
I'm just switching this.
So what's next after that? So what we've covered above has just reduced our document into a set of tokens. And we have now an introduction to NLTK. So let's talk about NLTK and how NLTK can help us do what I've earlier said. So we now understand what tokenization is. Tokenization is just breaking a document into words, right? So with NLTK, we just start by importing NLTK. We import NLTK here. Import NLTK. And from NLTK, we have a number of modules that can help us perform NLP. But for our purposes, we only need a standard tokenizer to help us tokenize our text into. So we need only the punct library. So we can set up and download punct by doing that. So you see, now we've downloaded part up here, and now we are organizing our documents into sentences or what. So you see that we have more power with NLTK. Instead of only breaking it down to one word, we can now have sentences. We can tokenize into sentences, right? So you see here, from NLTK, send tokenize. Sentences is equal to, so with the send tokenize, is now help us tokenize a document into sentences. And for the word tokenize, helps us to tokenize a document into words only. So you see, with a bigger library comes more power, right? Yeah. So let's keep going. Okay. So let's move. So we tokenize our words, and now we want to clean. So cleaning is just the same. We remove punctuation, remove text characters, but now here is what is important. Let me cover the stop words. Stop words. So stop words are common in natural language processing. These include you, they, it, and so on. But with NLTK, it provides us a pre-assembled list of stop words. So, for example, maybe one of my weaknesses, and when I'm on stage, I say a lot of So is a stop word to me, right? It's not really important if I just add it to my speech. You understand the concept of stop words. So I now want to remove those stop words and have a really nice presentation when I come on stage here at Pycon Uganda. So that is why I use whether I want to remove those stop words. But how do we remove them? We have a set already predefined stop words that you can now say, hey, Python, remove if this stop word is existing in my text, please remove it, right? And then they remove it from the text. And that is what that block of code is able to do. Okay, so now let's dive deeper into this. We've removed all the stop words. Now we have the concept of also stemming. So stemming is the process of bringing a word to its value. As I said, we clip the stems from a word. So take for example, we have acquire. It comes from the word acquire, right? So if acquires anything, you have to bring it down to acquire. Say earlier shared. So and this is we have when we're using a word, NLTK provides the pod stemmer that you can use to stem our words. And you see I've imported it and I have now stemmed the word, and now you can see how when you see like a picture that remove the E at the end, where it's in chapter. You see now you have more. So that is what we have. So we tokenize and clean it again. Okay, so now let me come here first. So when I use a vocabulary in natural language processing, it just means my document. So my document has different words. It has a set of tokens that I've shared. Now it becomes what you have called a vocabulary. So now a vocabulary means set of tokens. And now when you have a vocabulary, then you can proceed to actually building the application. So now let me go straight to that part. I can actually do this. So yeah, that was just like to help you understand what exactly that means. So the first thing is we read. For now, I want to explain the concept of embeddings here. But first, for this lab, we are going to use another text. We're going to use a nursery rhyme for 20 documents. So you can see that this is the house that Jack built, this is the cheese that they lady, the house that Jack built. So the first thing, as always, we read our data, and how we read our data, just you say docs is equal to, then predefine the text, and then we have what you call a bag of words. So with the document loaded, our first step is to construct a bag of words. We can now use this using the count vectorizer. So vectors are really an important concept when it comes to NLTK, because now with vectors, how we're going to measure similarity of words. So we have, in vectors, we had a concept of cosine similarity, where we are trying to use the cosine to find the similarity between two vectors. So here too, we will convert the numbers, the words, into vectors. And after converting them to vectors, we now use what we call, that is just one thing that we can use, cosine similarity to find the similarity in this number. That is just one example. Because you can find, for example, one has used, if we find that our word appears det, we turn that one as negative. So when our chatbot receives that measure that contains the word det, know that, okay, so this thing is have the negative that the customer is trying to tell us. You understand that concept of this, right? Okay, so now we will construct that. So after constructing that, I've told you that vocabulary is just a list of tokens, and tokens is just so now we need to do this. So when you want to score documents, we score documents with the frequency of words that have been ignored or common. So a better method of scoring documents is called term frequency over inverse document frequency, or TF-IDF. So this can be big terms we were right now, but it is very simple once you get deep into this. And the good thing is this code that you can access it from anywhere and actually find me around here. Because the time is running out, you can catch me anywhere and ask me to explain to you anything. So now we want to now score the words, like how close are they? Are they negative words or positive words that these customers are sending to us? Is this customer giving us like a good thing or a bad thing so that we can give we can give more good service to them? So after that, I explained we have this concept of cosine similarity. So in order to measure the similarity between two documents, or in this case, verses, so we use a saw, right? So how similar are two verses? So there are a number of methods that you can use to measure the distance in any n-dimensional vectors. So that's why I say we're using vectors. So to measure the distance between any vectors, you can use what we call cosine similarity. And that is the formula. And the distance calculated will range from either 1 to almost exactly negative 1.0 or similar to that. So for example, here you see you can see an example here where you measure the similarity of something. Yeah, so you can quickly measure the similarity. So you can see that in measuring the similarity, we have 0.7. For all these numbers, that we can better have them. And now let's check the embedding classes parts of it. Okay. Yeah. So we can also measure word similarity in a similar manner by a concept that is called word embeddings. Word embeddings are vector representation of words, learned from either statistical or deep learning model. So a vector representation of a number of words. So we are changing the word into vectors, and then you are representing them and measuring the similarity of those words. And now this is how we do it. We want to tokenize and all that. We've covered this before. So I'll just go to the bottom part and show you how the similarity happens. Yeah. So you can see here in the word, if I wanted to make similarity between two words, let's say Jack and rat, you see it's giving us negative 0.0512. So it means that these two words are not really, because Jack is a name, but if you had two similar words, it would have given us a better thing. So this is now the concept. I hope I've broken it down little by little till now you understand what exactly it is, right? Yeah? I know it can be, I really wanted to bring in the mathematical perspective because that is really important in machine learning. You can't escape it. It's not like hard math, but it's really easy math that you can work around. So I feel like I want to respect the next speaker's time if I take questions because you can see the MC already on stage. So what you can do, maybe you can bring back this, like a minute. You can you can bring back the slide and then we can finish up. Yeah. So let me finish up in just a minute. Yeah, so we talk about that. So you can find all the resources for this talk in this link. And in that link also you can also find where to reach me and all that. So I will have this slide distributed. I share them with the organizers and they can create a folder related to the event. You can also get access to the slide